Hi guys, welcome to ChipCraft where we turn logic into silicon. In previous lecture, I shown you how to download tools which are basically open source, and we also perform one test case to make one chip. I hope you all followed the lecture and made your chip. If not facing any issue or error, please comment it down. I will try my best to resolve your issue and you will also able. Today we will understand what synthesis really does, what are the inputs to synthesis, what we can expect the output of the synthesis, what are the roles of standard cell libraries, how OpenLane uses for synthesis. I already told in my previous lectures like OpenLane is basically a package which uses different tools. What is logic synthesis? So story begins with an idea. Idea can be written in language. Industry standards languages are Verilog, VHDL, System Verilog, and C also. So these ideas are written in a file we called as RTL files. Later on, these RTL files are converted into gate-level netlist with the help of these synthesis tools. So if I talk about what is logic synthesis in a one sentence, then it will be perfect to say logic synthesis convert RTL into a gate level netlist using standard cells like AND or NOT gate like this. Let's see what are the inputs to synthesis tools are. First one is the RTL file in which ideas are written in form of any language. Second one is the constraints. It is written in SDC file. Main command of SDC file is to define a clock period. Third one is the standard cell libraries. We call them files as a liberty file in which several numbers of universal and non-universal gates are there, in which their timing characterization, capacitance, lookup tables, lot of things are there. We will talk about these files later. Then fourth one is the optional for this synthesis, which is the technology file. This technology define which node you are going to working on. From the word standard cell, I mean pre-designed logic blocks. They carry all digital gates. They all are characterized for their timing, power, area. These all information we can found in the Liberty file. These information later on calculated by the tool and decide whether our chip is going to meet our requirements or not. Now we will see what are the output of synthesis. In the input side we given a RTL file. Suppose it is written as assign y equal to a ampersand b. Now tool will search available gates from the Liberty file and try to implement this logic. So tool is not getting a AND gate directly, so it put AND plus inverter. Here we can see first gate is AND2 x1. AND2 means it has a two inputs. X1 is its driving strength, which is belongs to fan out. We will talk about fan out also. And this is and next one is the U1, which is the instance name, and next are the ports name A, B, and Y. Similarly for inverter, X1 driving strength, U2 instance name, and A and Y as a port name. Along with gate level netlist, we also find some reports from which we can verify the requirements met or not. Basic reports are placement reports, timing reports, and power reports. In placement reports, we will see number of cells we used from the library, number of flops, total area of the chip, and in timing reports we will see whether the clock period we are given is suitable for the chip or not. And in power reports we will find the leakage power and the total power done by the chip. Our goal for synthesis is to meet the timing, we have to minimize the area as possible, reducing the leakage power, total power. In next lecture we will see all these reports and gate level netlist in our open lane. uh, Basically the synthesis done in open lane is uses whatever the script we followed for doing the synthesis, we will also see that. We will see what the tech which tech file we are using here. Actually this synthesis whatever we did here is very simple. It doesn't have much complications, but in real world there are too many concepts in synthesis also. One of which is MCMM, multi-corner multi-modes, in which we made a single chip behave like it can be used in a slow process, fast process, hot environment, cold environment, because the behavior of transistors get changed according to the environment in which we are going to use it.